A previous video talked about how to choose the best kinematic equation, and this will build on top of that and actually using the kinematic equation to solve questions. So our first question we have over here is the car is traveling to the right with a speed of 42 meters per second. When the driver slams on the brakes, the car skids with a constant acceleration before it comes to a stop. So 4 seconds, that's time. And then it ends at velocity of 0. So which kinematic equation would you use? Okay, so let's see what we're given. We have the initial velocity is 42. We have time is 4. It tells us constant acceleration, but we do not know it. And what else? We have the final velocity, which is 0 because the car comes to a stop. And it's asking for displacement, so delta x. So let's see if this checks off the box. Nope, this does not have delta x, so it can't be it. We have this, we have this, and we have this, and this is our unknown. So this one works. Let's see. Equation 3, we have delta x, but we do not have acceleration. This we do not have, so these equations won't work. So we have to use equation 2. 42 meters per second is our initial velocity, so delta x is equal to 42 plus 0 over 2 times 4. So the answer to the first question is 84 meters. Now we're going to use the same kinematic equations and try to solve this question. A bumblebee is flying to the right when a breeze causes the bee to slow down with a constant leftward acceleration of magnitude of 0.5 meters per second squared. So we have acceleration. After 2 seconds, the bee is moving to the right with speed of 2.75 meters per second. Okay, so we're given time and we're given velocity. And the acceleration is actually going to be negative because it says it's a constant leftward acceleration. So let's see what we have. We have a is equal to negative 0.5. Time is equal to 2. And velocity is 2.75. So what was the velocity right before the breeze? So it's asking for V naught. So now let's pick the question. Which equation does not give us V naught? So all these equations give us V naught, but which one gives us acceleration time? Which one has acceleration time and velocity? So this one has acceleration time and velocity. This one does not have acceleration. This one does not have acceleration. This one has acceleration, but we do not have delta x. Same thing over here. We do not have delta x. We don't know it, so we can't use that equation. So we have to use equation 1. Equation 1, we have velocity as 2.75 meters per second is equal to v naught plus acceleration times time. Remember, acceleration is negative 0.5 because it's moving in the leftward times 2. Time is 2 seconds. And then we solve this equation, 2.75 is equal to v naught minus 1. So v naught is equal to 3.75. So the answer is 3.75 meters per second. Now moving on to the next question. Next question is also similar, so I suggest trying to do it first, or at least trying to figure out the kinematic equations, and then I'll explain it. Okay, a car is traveling to the right with a speed of 29 meters per second. And then the driver slams on the accelerator to pass a truck. So it goes 29 meters per second first, and it's accelerating. And then it passes the truck in 110 meters, so that's delta x, and it reaches speed of 34 meters per second. Okay, so we have the initial velocity of the truck as 29, the final velocity as 34, and we have delta x as 110. So it's asking for the acceleration. Let's see. So we need all v naught, v, and delta x in our equation. One does not have this. We have delta x, v naught, no x, no displacement. No, we do not have time, so it won't work. We do not have time over here. And we have to use this equation because all of these have time in them, and we're not given anything related to time. So v squared, final velocity 34 squared is equal to 29 squared plus 2 times acceleration times 110. So now I would just suggest using a calculator to solve this question and figuring out the acceleration. So that would be you do 34 squared. So that should be about acceleration should be about 1.43 meters per second squared. How you can do this is 34 squared minus 29 squared is equal to 220a. Divide both sides by 220, and then just use a calculator to solve this. Moving on to the next question, we have a dog walking to the right with a speed of 1.5 meters per second and sees a cat and speeds up with a constant acceleration with a magnitude of 12 meters per second. All right, so what do we have here? We have velocity and speeds up with this acceleration. So what equation are we going to be using? If we're just looking at it, looking at the question, we do not have time at all. We have no indication of time. So none of these equations would be working because if we don't have time, it won't work. It's asking what was the velocity of the dog after speeding up for 3 meters. Okay, so it's asking us for the final velocity. So v squared is equal to the initial velocity squared, 1.5 squared, plus 2 times the acceleration, which we're given over here as 12, and delta x, which we're given over here as 3 meters. So now we just solve this. You can use a calculator, solve this, and you would be getting 8.62 meters per second. So if you're wondering how you do this on a calculator, first you have to solve this entire portion, just see what you get, and then you have to take the square root of the entire thing. So 1.5 squared plus 2 times 12 times 3. Well, that one's a little bit slanted, but yeah, you should be getting an answer around this.